Hello everyone, I wanted to quickly go over temporal logic. So temporal logic is a specification language. We basically have a system. It can be a hardware system, it can be a software system, it can be any kind of system that have a certain specifications, and we are trying to model them, to capture them into a model, like be able to express them basically. And in this class, we're covering two ways of doing this. The first one is linear temporal logic, or LTL, and the other one is branching temporal logic, just TL. An example of this is CTL, computation tree logic. Okay, so what is the difference? When we say linear temporal logic, we're expecting a structure that is linear, just like this. Here, I have to call one of these. It's a set, it's not really a state, but I have to specify where I'm starting. So if this is the first set in my structure, I'm gonna call it S0. Now, if I say that at S0 I have X, 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 B, for example, just very randomly, what does this mean? It means an X here is next. It means that on S0, let me actually label them, S1, S2, S3, and so on. So it means that in S0, this property is true. At S0, I know that next state, next state, next state, B will be true. This means that here, X, X, B, next one will be XB. This means that this is B. So this one means that the next one will be this one, and this one means that the next one will be this one, and this one means that the next one will be B. So here B will be true in S3. If I say, just another quick example, a lot of people confuse this sometimes, but very quickly, since we haven't really, just a reminder, X means next time, next set. G means global. F means eventually, like sometime it will happen. Okay, global, or like every time, every single time. So if I say here at S0 I have GB, B is global. What does this mean? A lot of people will say, it means that B is gonna be true in every single state in the future, but as we covered in the class before, the present is part of the future, so B has to be true in that same state where we say GB. Okay, so that's very quickly linear temporal logic. Now, what is branching temporal logic? I just want to highlight something here very quickly before we move on into this. Branching temporal logic is a bigger set in which linear temporal logic is a subset. So if you focus on one of those branches, this is just a linear structure. This is LTL, right? So linear temporal logic is a special case of the branching temporal logic. So if you have a question and I'm asking you to draw a model tree B like this, and it says XXGB, for example, you can either use this or you can use the linear one. I don't care, because it captures the same meaning. But if you have a path quantifier, like all the path, or this is very close to like for all, for those of you who might have covered this in maths before, and E for there exists, also similar to the there exists expression in math. If you have one of those, this is trying to specify a path in the branching model, so you cannot use this one here. This is an oversimplified linear version of this.